Hello, it's my great pleasure to bring you the second video in the chemistry naming series. For this one, we are going to be specifically talking about, for the first time and first of 3 times, so the rest of the videos this semester will be about ionic compounds. We're going to be talking about if there is, again, a metal, which will make it ionic. The first video, if you need a refresher on, is on covalent naming. That is down here. But today we're going to shift gears and start to focus on ionic naming. So essentially, ionic is when you have a metal plus a non-metal. So really the question is, what kind of metal is it? I mean, that's really what it's going to come down to. So is there a metal? Yes. Is a metal a transition metal? No. So what we're going to specifically do today is talk about this little chunk, which is about ionic, what I call phase 1, or basic metals. What you're going to do is you're going to name the metal first, and then name the second one, changing the ending to "ide." This part with the "ide", just as a refresher from video 1, is the exact same as the other one, and it's for the exact same reason. If you have an ion of any kind, as I scroll back to the last video, it's going to end with "ide". So if you're using charges from the periodic table, your +1, your +2, your -1, your -2, the ending is going to be "ide" every single time, unless, again, it's on the back. Which, fun fact, this is the next video. So we will not be talking about this for the rest of the video. So first we need to review crisscross. So essentially, what you need to do is you need a positive to go with a negative. If you put 2 positives together, for example, like this, or if you put 2 negatives together, for example, like that, one, besides both of these repelling because they're both positive, this won't work. So this won't be a thing, and this won't be a thing. So what will we do? So instead, what we're going to do is we're going to put chemicals together. These, as a refresher, are cations because they're positive, and these are anions because they're negative. Think cats have paws, and these are positive. Haha. So if that helps anybody, especially since we're tomcats, I think that'll be a good little thing to do. Now, here's what we're going to do. If I have a +1, if I have lithium, and I'm putting the lithium together, for example, with oxygen, you'll notice immediately that this isn't going to work because overall the charge of this is -1. That's a no-no, okay? So from doing the crisscross, you would know that this is not stable, which means it's not actually going to happen in the real world. So again, this, well, is wrong. So we need to think to ourselves, what do we need to do in order to get this to work? And you'll probably notice it a few different ways. First off, metals are always first, and you probably will notice I need 2 positive 1s to balance out with a -2. If you add these 2 together now, you have +2 with a -2, well, that equals 0, and that is stable, which is wonderful. So again, there's a lot of different ways to do this. This is a visual way of thinking about it. With the crisscross, what actually ends up happening as well, for those of you who would like to see it that way, if you have lithium with oxygen, and if you have a +1 with a -2, again, these are all from the periodic table. So every single person should have a way to access or label the charges on here. I'm not going to do that for this. And you can crisscross it. So this 2 goes here, and this 1, which you don't have to write, goes there. And if you'll notice, Li2O, well, there's 2 Li's and 1 O. So I'm not going to be doing this on the next 2 videos because this will work for all of ionic naming. So if you need to go back to this, please, on your leisure, feel free. And I'm going to stand this out a little bit so you know just how important this is. Having a stable chemical is important. If it's not stable, it does not work. So let's jump into some problems. So here's what we have for these. So just got a few over here, and I'm not going to do all these. We're just going to do a few. So for example, what I personally like to do when I see the words, well, I like putting the charges above the words. And I will do that for all these. Lithium is a +1. Bromine is a -1. Notice I know bromide. Notice all of these end with "ide", just like covalent naming, just like I said earlier in this video. Magnesium is a +2. Sulfide is sulfur, that is a -2. Potassium is a +1. Barium is a +2. Aluminum is a +3. Beryllium is a +2. Nitrogen is a -3. Oxygen is a -2. Fluorine is a -1. And phosphide, is a -3. So when you're putting these together, you just need to make sure that the charges are stable. And again, you could do it either with the crisscross like this, where you're literally going through and, pardon me there, crisscrossing those numbers, or you can think about it conceptually, how can I get this to be 0? Either way, you will get the right answer. So really quickly, and I'm just going to do a few of these, what ends up happening is lithium bromide is a +1 and a -1. That is absolutely wonderful. This would be LiBr. It's a tie. This one is also a tie because you have a +2 with a -2. So this one's just going to be MgS. This one, aluminum fluoride. I have 3 right aluminums +3, and I have 1 fluorine. So that is going to be Al, cross it over, 1, which you don't have to put, F, cross the 3, 3. And again, you would be writing these low for speed. I don't know if I'm going to be able to do that. So this, actually, you know what? I'm going to do it. It's going to look like that. And then this one, the more crazy one, Be, that 3 is going to come over, P, and then that 2 is going to come over. This also works because for 2 and 3, the least common multiple is 6. And if you check the math on this, 3 positive 2s is +6, and 2 negative 3s is -6. So this is stable. So hopefully not too bad. That's how all these work, right? And with these, you could argue it's a little bit faster. That's calcium. That's fluorine. So that becomes fluoride. And again, like I said in the first video, please forgive my spelling mistakes. It's going to happen. I'm just going to be honest. You'll notice with all of these, and you'll see by this name here, there will be no prefixes. Prefixes is a specifically covalent thing, so ionics will not have any prefixes. Okay, and I will say this in the other 2 videos as well. This one is lithium. And oxygen is oxide. Again, no prefixes. And that's really how these work. And for example, just to do one more, this one is gallium, and Cl is chloride. So personally, I think these are easier because you just have to look what they are on the periodic table. Here, really recommend doing the charge thing that I did. Really recommend that because it really helps you see that crisscross faster. And that's how you do what I call phase 1 ionic naming, which is just the basic metals with your nonmetals.